Whoa! Alright, here we go. I'm moving that down a little bit. Mainly because I can. Alright, so I like a domain of all real numbers. X can equal plus or minus 2. That tells me then that I have some vertical asymptotes at x equals -2 and x equals 2. Like it. Degree on top. Degree on the bottom. Those are the same. So my horizontal asymptote is y equals 2, because it's 2. My lead coefficient on top is 2. Lead coefficient on the bottom is 1, so it's 2 over 1, which is 2. Okay. F of 0 is going to be 2 times 0 squared minus 9 all over 0 squared minus 4. That's going to be 2 times -9 is -18 all over -4, which reduces down to positive 9/2. So that gives me a y-intercept of 0, 9/2. Set the numerator 2 times the quantity x squared minus 9. Set that equal to 0. And then I get x squared minus 9 equals 0. Then that gives me x squared equals 9er. Then that gives me x equals plus or minus 3. So that tells me I have x-intercepts at -3, 0 and positive 3, 0. What happened to what 2? I divided both sides by 2. Okay. So, 1, 2, and 3. So I've got 1 there. 1, 2, and 3. I got 1 there. Oh, working backwards. 9/2 is 4.5. 1 and 2 and 3 and 4 and 0.5. I got a horizontal asymptote at 2. Nailed it. And I've got a vertical asymptote at x equals 2 and x equals -2. With me? Okay. So then we have to do some figuring. So our function again was 2 times x squared minus 9 all over x squared minus 4. So I like apples and bananas. 1, 2, 3, 4. -4. Probably can go with +4 then at the same time. And then let's do -10 and +10 at the same time. In the midst, let's do -1 and +1 at the same time. So, -4 squared is 16. 16 minus 9 is 7. 2 times 7 is 14. -4 squared is 16. Minus 4 is 12. 14 divided by 12 is 7 divided by 6, which is more than 1, but less than 2. -10 squared is 100. Minus 9 is 91. Times 2 is 182. Divided by 100 minus 4 is 96. It's not quite 2, but it's pretty close. Plug in negative 1. Negative 1 squared is 1 minus 9 is negative 8 times 2 is negative 16. 1 squared is 1, or excuse me, negative 1 squared is 1, minus 4 is negative 3. Negative 16 divided by negative 3 is positive 5 1/3. Now, notice how it's all squareds in my function, right? That means that the opposites are going to be the same. So this is going to be negative 16 over negative 3. This is going to be 14 over 12, and this is going to be 182 over 96. All going to be the same. Same. Ooh, that's 1, 2, 3, 4, 5, and a third. 3, 4, 5, and a third. Comes in from here. And down. Thing of beauty. And then from there I can get all of my end behavior asymptotal behaviors that I want. Okay? So as x goes to positive infinity, my function approaches 2 from below. As x goes to negative infinity, my function approaches 2 from below. As x approaches negative 2 from the left, my function goes to negative infinity. As x approaches negative 2 from the right, my function goes to positive infinity. As x approaches positive 2 from the left, my function goes to positive infinity. And as x approaches positive 2 from the right, it goes to negative infinity. And end behaviors. Good times. Okay? Good? Oklahoma, where the wind comes sweeping across the plain. What if my fraction, remember we're dealing with a fraction basically, right? What if my fraction has common factors? So for instance, let's say we had a fraction that was 6 over 8. Do I like 6 over 8 as a fraction, as an answer? No, why not? How? Divide both top and bottom by 2, right? So I could divide up here by 2 and divide down here by 2, and then that gives me 3/4, right? And it's simplified. It's reduced, whichever one you want to call it. What if we had 14x over 12, let's go x squared. Do I like that as an answer? Why not? What's up there? I can divide both top and bottom by 2x, right? I could factor out a 2x, if you will. And then that would leave me with 7 on top and 6x on the bottom. YB? Yeah, buddy. Yeah, buddy? Yes. Okay. What if I had that? You had me, then you lost me. So what do? I could cancel out the x plus 3 on the top, along with the x plus 3 on the bottom, right? So then that would just be reduced to this one. Right? Okay. What if I had that? What? Gonna factor the top? What is the top factor to be? What is the top factor to be? What is the bottom factor to be? Then what? Now I can cancel out the x plus 3's. Okay? Don't just cancel out the x squareds. Okay? You can't just chop off the x squareds. Okay? You've got to factor it. And so then now I can factor out the x plus 3's, and then that leaves me with, it was the exact same problem. I just multiplied it out. Okay? So, what if my function has some common factors? What do I have to do first? So if I have common factors, I need to simplify first. Now, way back when we started this process, I told you to save some space on your note card above step number 1, right? Because we're going to add in step number 0. Okay? Step 0 says you have to simplify. And you have to do it before you do anything else. Because otherwise, your graph is going to be wrong, your vertical asymptotes, all that other stuff is going to be wrong. Okay? You're not going to be graphing the correct one. Alright? You need to simplify first. So that's why we do this as step number 0. Okay? We do the simplification first. Because I didn't want to start you on step 2. Because then for the last 2 weeks I would have had to answer questions. Linz, why are we starting on step 2?
Well, you could have started out with simplified and made her now.
Have we had any that have done that yet? No. Because what, Matt, does simplifying do? No. Simplifying leads to step number 5, which is finding holes in your graph. Okay? So if something is able to be factored out, that then leads to step number 5, which is finding the holes. Okay? So, common factors is what they're called. Make holes. So common factors make holes. Yes, ma'am?
So you're saying that at x, when x is -3 on the graph?
In that last problem, when x is -3, or wherever the function is at x equals -3, there is a hole in the graph. Yes? Okay. So let's do one. Okay. Let's do one first, and then we'll work in step 5 into it and what you all have to do with step 5. Okay.
To do this, you can cancel x minus 2 over the top.
Your what hurts?
When you factor the bottom, you cancel x minus 2 over the numerator.
Yeah. Why do you think we're doing that? Hi, caramba, Matt. Okay, ready? So, as Matt said, this top is x minus 2, but the bottom here is x minus 2 and x plus 2. Right? Yes'm? Okay, so what can happen there? X minus 2's cross each other out. So that leaves me with what, Wesley? 1 over x plus 2. Okay? Now, that function is what I use from now on. Okay? This is my new function that I use from for the rest of the problem. What's up? I don't care about that other one at all. Okay? Alright? I'm caring about my new function.
Well, why does factoring it make it more accurate? And couldn't you just plot the graph and you find the holes that way?
Because this one over here, my original one, right, has 2 vertical asymptotes, right? Okay? Alright? Which means then in the middle, I'm either going to be a parabola or I'm going to be a snake. Right? Okay? This one, my new function, only has 1. So now I'm just going to be kind of like those exponential type ones on either side. But one of the sides is going to have a hole. Okay? So, new function now. What's the domain? That gives me a vertical asymptote at x equals -2. Okay. Degree of the top, 0. Degree of the bottom, 1. That tells me that top is less than bottom. So my horizontal asymptote is y equals 0. F of 0. 1 over 0 plus 2 is going to be 1/2. So that tells me I have a y-intercept at 0, 1/2. Numerator equal to 0 tells me that I have an x-intercept of what's my x-intercept? No. None. Because 1 can never equal 0, correct. Okay. Let's put all that stuff on there. Two. 0. No. Okay. All right. Now, I had a common factor, right? Because I factored something out. So let's do here now step 5. Step 5 says that I factored out x minus 2. So I set my common factor equal to 0. So that gives me x minus 2 equals 0. Right? Solve it. That gives me x equals 2. With me? I take that value of 2, and I put it into my new function. So that's going to be 1 over 2 plus 2 is 1/4. So the hole that I have created is at the point 2, comma, 1/4. So I go to the point 2, comma, 1/4, and I put an open dot at that point. Now the trick is, when I'm going to draw my curve, I can't just draw it right through the hole. I have to lift up my pencil or my pen, or in my case, finger or marker, and then re-put it back down. Okay? Step 7 says find extra points. So over here I'm going to go -3, -4, -10. Over here I'm going to go -1 and +10. My new function again was 1 over x plus 2, if memory serves me right. Yep. Okay, so -3 plus 2 is -1, so this is 1 over -1, so that is -1. -4 plus 2 is -2, so that's going to be -1/2. -10 plus 2 is -8, so that's going to be -1/8. -1 plus 2 is 1, so that's there. 10 plus 2 is 12. Down there. Okay. So I get that side. And then on this other side, I have to lift up so that I have a gap in my function. Okay? Questions on that? Yes, sir. Then end behavior and asymptotal behavior is the same. So then end behavior here would be as x approaches positive infinity, my function approaches 0 from above. As x approaches negative infinity, my function approaches 0 from below. As x, now I only have to do one asymptotal behavior, or each side, but there's only one asymptote, so there's only 2 there. So as x approaches -2 from the left, my function goes to negative infinity. As x approaches -2 from the right, my function goes to positive infinity. Okay? So I still have that, all of that stayed the same. Okay? It's just now the only thing that got added was this hole right there. Okay? Carson. Common factors is what cancels out. Yep. Matt, was that your question? Okay. Try that one. All right. I'm not going to drop my new mic, though. Okay, so there's that. So then the x plus 6's cancel each other out. So my new function is 1 over x minus 1. Okay?
I'm guessing there's ways to find more than one hole.
If more than one thing cancels out, yep.
So what do we have?
Yep, yep. You can have as many holes as things that cancel out.
Will we ever have it when the whole function cancels out?
No.
Wait, is it just for the denominator? Is that what functions are, or is it what if it's in like the numerator?
Then it's in the numerator, and you graph that function like you would normally graph that function. So vertical asymptote is x equals 1. Top is 0. Bottom is 1. That is, top is less than bottom. So that gives me a horizontal asymptote of y equals 0. F of 0 is going to be 1 over 0 minus 1. That's 1 over negative 1. That's negative 1. So my y-intercept is 0, comma, negative 1. Numerator. Oops. Put the 0 first. 1 equals 0 says x-intercept is none. X plus 6, set that equal to 0, so that gives me x equals negative 6. So I find f of negative 6, that's going to be 1 over negative 6 minus 1. That's going to be negative 1/7. So the whole is at negative 6, comma, negative 1/7. X equals 1. Y equals 0. Zero comma negative 1, negative 6, 1, 2, 3, 4, 5, 6, comma negative 1/7. There. My function was 1 over x minus 1. I would only need really over here negative 10. And that's going to be 1 over negative 11. That's going to be right up tight to there. Over here I would need 2, 3, and 10. So 2 minus 1 is 1. 3 minus 1 is 2. 10 minus 1 is 9. So that gives me 1, 1/2, 1/9. There, and there. Comes in. Comes in. I lift up. And there. And again, I can do asymptotal behavior, end behavior, all that stuff, then right off the graph. Yes, sir.
So what if the whole doesn't mess with the asymptotal behavior and behavior?
Whole does not mess with the asymptotal behavior and behavior, no. Actually, what the whole does is it gets rid of one of the asymptotes. Because this function should have had an asymptote at negative 6 and positive 1. We only ended up having at positive 1 at negative 6, then it's just a whole. Go for it. just keep doing your work. I'm just talking to all my internet followers. Well, yeah, it's all posted up on the YouTube. You think I just post this on It's Learning for you, Matt?
You can actually make some bank off of that. Make it popular. Yeah. There's some math teachers that have YouTube channels like
I have one.
10,000, bro.
I don't know what's all on it, but I just take the videos that I make here, the screencasts that I make, flop them on YouTube, and then dump that link then into It's Learning. There's a few things on YouTube, Matt. I know. X minus 1. See, I do mine ad free. I don't need no stinking ad money. So the whole is at 1, comma, 2/3. So, whoa, whoa, whoa. 1, 2, 3, 4, and 5. There. 0 is there. Y-intercept is there. Whole is there. What's my function? 4 over x plus 5. So I need -6, -7, -10. -6 is going to be 4 over -1. That's -4. 1, 2, 3, and 4. -7 is 4 over -2. That's -2. -10 is 4. Actually, here, let's be smart. Let's go -9. 4 over -4. So then over here, if I went -4, I'd have 4 over 1. 4. -3 would be 4 over 2, which would be 2. And then -1 would be 4 over 4. Okay. So then this bad boy comes in, stop, jump, go. And down. Okay? Alright. Hold on. The new equation one?
Yeah, the new question.
Okay, got it.
Now let's say there's still like by the 4 or some sort of like x plus 3 or something like that. What should we get? Would that be part of
Part of the new equation.
would it be part of the whole or is it just the bottom part?
No, the only part that's part of the whole is what you factor out.